Good day. Today's video is going to be about converting binary in the purpose of binary. So let's go ahead and roll the video. Let's get to the beginning. So our current system we use, and we learned this way back in probably kindergarten, first grade, is base 10. So 10 to the power of 0 is 1, 10 to the first power is 10, and so forth. So we can reach really large numbers by just adding more sets. So to the fifth 100,000. So you have one placeholder, you can go up to the highest number of 9. So base 10, it starts at 0 and goes to 9. So that's 10 numbers. So if we want to get above 9, add another placeholder. Now you're at the hundreds. If you want to get higher numbers, you go to the thousands and then the 10,000s. Binary is base 2, based off of the 1 and a 0, and it's used for storing data. So it's electrical charge or magnetic. So we need this to store data and also to create the operating systems and things like that. So our human language, it boils down into, and even computer languages like Python, into ones and zeros. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, and so on and so forth, all the way to the 7th. So we know that there's 8. So if you have a 1 and a 0, you get the on and off switch symbol. So here we have our placeholders. So if you just take this chart and chop it down, and it just kind of, the 1 falls at the end. So we always start from left to right, like we read. And so to compute binary, all you have to do is fill in if it's a 1 or a 0 in each one of these placeholders. So if we put 1, 1, 1, 1, 1, 1, 1, 1, you add up all those numbers. And I like the easy combinations here. So 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240. And then I kind of combine these last 4 bits. So there's 8 bits in a byte. And then these are all common subnet masks. So the highest number we can reach is 255. So let's learn how to convert. So we have our chart, and then I have these little easy reminders up here for the easy combinations, I call them. So all I have to do is get close to the number, because I know that the last 4 bits add up to 15. So to convert it, so we look at can we turn on the 128? No. Turn on the 64? No. Turn on 32? No. Turn on 16? Nope. So if we had 8, that's 8 plus 4, 12, 14, and now 15. So that's an easy way to convert. So let's go to 19. So we know that none of these big numbers can be turned on. So we can make sure they're off. So we do need the 16 on, and now we can go jump down to be what, 16 and 3. So we can turn off the 8, turn off the 4, turn on the 2, and turn on the 1. So 16 plus 3 is 19. So let's go big numbers. So this is an easy one. So we turn on the 128, and then the rest stay to 0. Let's go back real quick. So once again, turn on the 1 under the 128, and the rest are off. 153, so we definitely need the 128 on. We don't need a 64 on. We do not want the 32 on, that's 160. And then 128 plus 16 is 144. And then 144, I need 9. So it'd be an 8 and a 1. There you go. So I get the big number, and I go down to the smaller numbers here, the 8 and a 1. 201, big number. So we definitely want the 128 on. 192. If we go to the 32, we're going up to 224, so that stays off. Turn on 16. Nope. Turn on the 8. Now we're at 200. And then we need the 1. Turn off the 4, turn off 2, and turn on the 1. So once again, get your number, big number done first, and then go down to a small number, the 9. 226. Oh, that's an easy one. Look up here. Turn on the 128, turn on the 64, turn on 32, and then turn off the rest. Oh, got to get to 226. So we need a 2 and then 0 for the 1. So once again, get the big number and then you come down to a small number. Makes it easier math. 254. This is one I like because it's 1 less than 255. So it's always going to be everything on besides the 1. So in this way, you can add all these up like this, the big long way, or you can subtract the small number from 255. Just a little quick method if you want to do it, or you can just add them up quickly that way. So 175, let's go with 128's on, 64, no, 32 is 160, and then 15. So the 16's off, and then 1, 4, 2, and 1. So 88, let's start from left to right. So 128's off, 64 gets turned on, 32. Oh, so what do we need here? What is 16? 64 and 60. Oh, that's 80. So now we need 8. Oh, easy. Boom. And then turn off the rest. Boom, boom. So 64 plus 16 is 80. So let's make sense of binary, because what we're going to do is store this information down to the 1s and 0s onto some type of a magnetic storage. So here we have capital C, and here's our chart. This is a limited ASCII chart. It goes much bigger. So if we look at capital C, it's 67. So let's go ahead and convert 67 to binary. So it'd be the 64 on and then 3. Oh, that's wrong. I got to fix that. 121. So 121 would be 64 plus 32 plus 16 plus 8 plus 1. The better double check these. So the lowercase b is stored on the chart as 98. So it'd be 64 and 32 and 2. 101, 64 plus 32 plus 4 plus 1. And then 114 is 64, 32, 16, and 2. So when you get these numbers close, it becomes kind of easy. Now, do you believe people still program in binary? Of course they do, because they live in that environment. So I can do binary very quickly. We don't need to do it so quickly, just have to convert using some, simple math. So when we do hexadecimal, remember, we're going to learn hexadecimal next. That's base 16. So to overcome the limitation of binary, they made hexadecimal to get to really large numbers. So 67 would be 47 in hexadecimal, 79. So the Y would be 79 in hexadecimal, B would be 62, E would be 65 in hexadecimal, and also R is 72. So that concludes how to convert binary and read binary. And next we'll go to hexadecimal.